Hello everyone, it's Mr. Tanner. Welcome to STEM. Welcome to a little bit of a big study of big words. Our word for today is radioactivity. We're going to learn about it by reading about Marie Curie and radioactivity, written by Jordi Bayari. We're going to learn a little bit about what this excellent lady has to do with the study of radioactivity. I'm going to start by looking at the picture up here. I want to observe some things and make some predictions or some hypotheses, if you will. Marie Curie has, or I'm assuming that's in this picture. It'd be funny if they actually pictured someone else. But anyways, Marie Curie has some round bottom flasks here. She's also got a conical flask on a table, some beakers, and some test tubes. So I assume that she's doing some chemical experiments. I assume that she's studying radioactivity in some way. Maybe she discovers it. I also can assume from this, or hypothesize from this picture, that it was done a long time ago, because she's wearing this kind of old-timey dress, even though she's in a science lab. By the way, you can read this entire story on Epic. We are going to be reading part of it today because I really want to read the story, but I know that if I read the whole thing, it would take like half an hour, and I don't want to take quite that long. Maria Skłodowska was born on November 7th, 1867 in Warsaw, Poland. She was the youngest of 5 children. Her parents, both teachers, were very concerned about their children's education. "You must study hard, my children, not just for you, but also for Poland." At the time, the Russian Empire occupied much of Poland. Russia forbade the teaching of the Polish language and Polish culture. We tried to take our freedom through violence many times, but without success. That's not the way. The true way to make a country strong and free is through culture and knowledge. This idea you'll see play out throughout the story. Whenever Maria comes up against a problem, be it funding, the fact that she's born in a country that has a lot of limitations, or the fact that she's a woman studying science, which at the time really wasn't encouraged. All of these problems, when she comes up against them, she looks at knowledge and how she can make it work inside the culture that she's in. How she can help people through it. "But the Russians won't allow us Poles to study our own culture. They even send inspectors to check the schools." Can you imagine you're sitting in school one day and a guy comes in and is like, "Wait! You need to make sure that what you're studying and teaching here aligns with the viewpoints of whoever's in charge." That would be pretty ridiculous. But it's nonetheless it's what happened. And for that reason, and so, young Poles have to hide. We have a clandestine school, Flying University, where we can preserve our traditions. Clandestine, I believe, means like secret. And if you read this on Epic, then you can know for sure by clicking on the word. Anyway, that's why, my children, you have to study hard. Now, let's carry on with tonight's reading, A Tale of Two Cities by Charles Dickens. Manya, however hard we study, we won't be able to go to university. We have to know Greek and Latin. But here, they don't teach those to girls. We'll have to study abroad. You're right, Ronia. We could go to the Sorbonne in Paris, but how would we pay for it? One of us can study, while the other stays behind, working to pay for the lessons. Of course, and then the other way around. You're older. You should go first. I'll work. So look, already hit some problems, already came up with some solutions. I hear the Zurowskis are looking for a governess. Governess is a lady who goes ahead and teaches kids, usually like in a private home. 1889. What? You want to teach my children and the peasants' children? That's right, Mr. Zurowski. But if the Russians find out, the children have to learn. We must risk it. It's our duty as Poles. All right, but do it on your own time, and don't let anyone find out. Look what she's doing here. She's writing a problem on the board. She's watching the kids to make sure they're paying attention. And I think she's also looking out the window to see if anyone's peeking and looking in, seeing that she's teaching these kids. That's a pretty intense teaching job. Thankfully, we have freedom to teach. Manya, welcome to Paris. Now you'll have a chance to study. You can live with me and Kazimierz in our house. Thank you, but I'm going to rent a flat in the Latin Quarter, closer to the university. I'm going to devote myself to science. I have to make up for lost time and catch up with the other students. Sister, you're working too hard. Didn't your friend Professor Kolowski invite you to dinner? Go on, get some air. How are your studies at the Sorbonne, Maria? Very well, Joseph, although I want to start work on my thesis, and I don't have a lab. A lab is where a scientist will work. Ah, I know just the person to help you. Maria Skladowska. Let me introduce you to Pierre Curie. Pierre, Maria is a friend from Warsaw and a student here in Paris. Oh, really? What are you studying? I've just earned a degree in physics from the Sorbonne. I studied there too. We'll have to meet again to talk science. Don't you agree? I'm sensing some chemistry here. So what's your field of study, Mr. Curie? Well, my father was a doctor, so at home we had a keen interest in science. And, like you, I studied physics at the Sorbonne. And my brother Jacques is a geologist. Together we study the properties of minerals. We've even found that some minerals generate electricity if we apply pressure. We call it piezoelectricity. Look how smart he looks and feels. He's kind of showing off a little bit here. Together we built a piezoelectric quartz electrometer. It measures these tiny electric charges. But now my brother has left to teach in Montpellier, and I've ended up alone. My research has stalled, and I don't have someone to do it with either. Well, perhaps we could work together. And if you like, Maria, we could be more than research partners. Oh? Very bold, Pierre, but I don't know. I'm going back to Warsaw this summer. I don't even know if I'll return to Paris. Oh no, you must come back. You'll have to carry on with your thesis. We could even begin a great scientific project together. What a sweetie. I told my director at the School of Physics and Chemistry that we need a lab. He said we could use this warehouse, although it's not in very good condition. Maybe if we tidy it up, bring in some instruments. Yes, it'll do. I'm interested in the rays that Henry Becquerel discovered, the ones uranium gives off. I want to see if other minerals do too. So here we had our first inkling that she is studying rays and radioactivity eventually. When the lab is ready, I'll bring my electrometer. I'm sure you'll find it useful. And apparently these rays can be detected by an electrometer. How's it going? Well, I've been measuring the electric charge of different minerals we have on hand. The first was uranium, of course. It's the one Becquerel works with. But afterward, I tried some others. In pitchblende, the mineral where we usually find uranium, I noticed something very unusual. What's that? Well, based on the amount of uranium it gives off more rays than it should. I think there's something else in the compound, something unknown. Compound is a mixture of different elements. Mixture of different. Let's see.
Compound.
Yeah, so a mixture of different elements. Where were we? Oh. Obviously, a new element. I've decided to call it polonium after my home country. She's now discovered her first element by looking at the properties of this compound. And that's how scientists study things that are super, super small, like elements. 1898. See, from time to time, you should stop to eat and rest. I know, but I'm so absorbed in my work. I've discovered yet another element within pitchblende. It gives off even more rays than the others. I think I'll call it radium, which means ray. In Latin, its level of emissions is huge. So many rays. It's like kind of radioactivity. Yes, that's it. In fact, we're going to stop and look at a little image that I found. Spontaneous disintegration of atomic nuclei to release subatomic particles, or radiation. So, radiation, or radioactivity rather, is when an element is kind of unstable. The difference between positive and negative charges inside the element gets out of balance or is out of balance. And so as a result, it splits off subatomic, smaller than atom particles. And when it does that, it emits a ray, usually, or the most common types being alpha particle, beta particle, or gamma particles. Alpha, beta, or gamma rays, if you will. And that is what radioactivity refers to. That's what she's noticing. Although she doesn't really know it yet. It's too early on. Yes, you're right. Oh, she's looking for more pitchblende. Yes, you're right. I know a geologist at the University of Vienna. He might be able to help us. Most of our pitchblende comes from the uranium mines in Josephson. I'm sorry, I don't know how to say the word. We get a lot of it, but we don't have much use for it once we've extracted the uranium. Well, that's perfect for us. Without uranium in the mineral, it's easier to detect and refine the new elements. Then everybody wins! We get rid of our leftover pitchblende, and you get minerals for your research. For a reasonable price, of course. Ever the businessman. And we notice that she's come to a common problem that she faces. Funding. Getting money so that she can study. Learn about things. And eventually help people by learning about things. Mr. Curie, your minerals are here. Where should we put them? Here is fine. But all of them? And they say they're going to send more. So she's got to go ahead and refine all of this pitchblende so that she can do tests on it. Look how much she's got to work with. That's insane. Phew. Look, she's refining it. Refining the pitchblende to get the minerals I need is tough. We should be doing this at an industrial level. What if a business refined it for us in large quantities? So she doesn't just think of solutions to problems. She thinks of solutions to make something work better. So she could refine it. She knows how. But she thinks, there's a better way to do this. And so she goes to a business. Yes, our firm can do all that. But what will we get in return? Our knowledge and training. If you make products with radium, our laboratory can guarantee their quality. Then we have a deal. You have a mind for business, Madame Curie. And now you have our help with your research. And I'm going to kind of pause the story here because I don't want to go on forever and make this lesson indefinitely long. It's a great book. I'm about halfway through. We're going to go to the end, though. I'm try to get there without ending it like I did. I wanted you guys to see that there's a timeline in the back. That's the cool thing about reading nonfiction. It's a real story. There's a picture of Madame Curie. Or Marie Curie, sorry. And here's our big word for the week. Radioactivity, which is having or producing a powerful form of energy called radiation. And those are the alpha, beta, or gamma rays that I told you guys about. So you guys can go ahead and read that story more if you would like to. Some other notable things that I think we should notice is that Marie Curie was the first to receive a Nobel Prize in both chemistry and physics. And she got to name 2 elements. And those are notable things in the scientific community. All right, hope you guys enjoyed this. Hope you guys get some time to maybe go read this story on Epic. And hope you guys have a great week. Make sure you answer, hopefully I'll put up about 3 different questions that you need to answer.